Welcome everyone. I'm here now with Čermák, who will talk about the testing containers images with Python and Pytest. And before we start the session, I just want to remind for those of you who are joining us now that you can ask the questions in the Q&A section, and we will get back to it at the end of the session if we have time. And now, then, the floor is yours.
Thank you. So, hello everyone. Welcome to my presentation about a Pytest plugin called Pytest Container that's used for testing container images with Python and Pytest. So I lied a bit. This is actually the subtitle. Anyway, about myself, just briefly, I'm a software developer working at SUSE. I'm also active in the Fedora community where I do stuff with the i3 desktop, maintain a few packages, and besides that, I like working on development tools, testing, documentation, and messing with my Home Assistant instance and breaking all my lights from time to time. In case you still want to stalk me on social media, there's links below. But now to the far more interesting part, and that's testing containers with Python and Pytest. And first you might ask yourself, why the heck would you do that when there's shell scripts? Because shell scripts, they are portable and they run everywhere, even on your 20-year-old DEC VAX. Well, 40, sorry. They are reasonably fast most of the time. And everyone understands them, unless you do complicated stuff. But everyone understands them. So in principle, shell scripts can be used to do things. But let me put on my, I don't have a hat. So imagine I put on my salesman hat and try to sell you the Pytest container plugin, why you should use it or why you should give it a try. Well, first thing first, I don't agree that shell scripts are a great way for testing because actually they are pretty brittle. The shell is, at least the SH and bash is, in my opinion, not that great because if you want to do more complex stuff, it gets really ugly. If you have quoting issues with the shell, I mean, who knows how to properly quote and escape everything? And so at least if I want to write tests with the shell, I usually have to start testing my shell scripts. And when I write tests for my tests, that's the sign that I'm doing it wrong. So that would be one thing. So I really like to use Python and Pytest for that instead. And then, so also what this plugin can do for you is you don't have to pull or build images yourself, really. You just declare your containers, and the plugin will automatically pull them down, build them, do whatever is necessary to bring them up, and clean up after itself. You don't have to write code for that at all. It relies very heavily on testinfra. So this is a test framework also integrated into Pytest, which just provides a bunch of convenience functions for instance, to find out what's the contents of a file, which packages are installed, are there any open ports, etc., etc. So really nothing super complicated, but just everything packaged in one module and provided via a rather convenient thing. So then one thing I'm relatively proud of what we achieved here is all the tests can run in parallel. So all the functionality is tailored towards supporting parallel test execution via Pytest xdist. So you don't have to run all your tests on one core if you have a 40-core machine, or even more. I only have 12, but well, enough. The plugin will automatically find free ports on your machine for you and expose the containers via them. And that also works in parallel. And you don't have to parse the output of Podman inspect container yourself. So you get an abstraction for this as well. If you're using Podman, it supports the creation and destruction of pods, all again happening automatically. Same thing with container volumes. So in case you want to mount a volume or you want to mount a temporary directory into your container, it will do that for you as well. You can run the same test on multiple container images. For instance, you want to test some application on CentOS, OpenSUSE, Fedora, Alma Linux, Ubuntu Debian, etc., etc., for everything for which you can find a container. And you can do that rather easily. It supports Docker and Podman. You just set an environment variable and it will use either or the other. And it actually runs on Python 3.6 still, on x86, 64, ARch64, S390X, and PowerPC 64. The later two have been a kind of a pain, but it works. And it sort of even runs on RHEL 7. Sort of, kind of. No guarantees, though. Okay, so, and with that, let me give you a very brief example how such a test function would look. So you do the usual Python import your stuff. You declare your container. In this case, this is just a simple container. And then you write your test function. And in this case, this test does a rather simple thing. It just checks whether etc/os release is present. Nothing super complicated. But the nice thing is, if you would now put this in an appropriate file in a file system and run Pytest, essentially just Pytest and then the directory, this container would get pulled down from the registry, launched, then the test would start executing, and after the test execution finished, the container will get removed. The image will still stay there, so that you then have to pull it every single time, but the container will be then removed and nothing from it will be left over. So what can you use this for? Really, if you have base containers and you want to run system tests on them, if you want to test your containerized applications, this could be useful for you. Or if you have some scripts or applications and you want to run them on multiple OSs and you don't need VMs for that, or you don't want VMs or both, then this would be also useful for you. Good. So let's now dive a little bit more into the whole topic. So first, let me give you just a few Pytest basics in case you haven't used Pytest extensively before or not at all. So this is really just a Python testing framework because no one really uses Python's unit tests framework anymore, and this one is much better. What it does is really, you just point it to a directory, it loads all the Python files in there, and every function that's called test_something is executed. That's it, really. It's okay, I lied about that. The other big thing that Pytest supports are fixtures, which Pytest container heavily relies on. So a fixture is really just a magic function parameter. So take a look at this really short example. So in this example, the SMTP connection, underscore connection, that's a fixture. So in reality, this would be a function which would establish an SMTP connection. It will then you can use it in this test. So it will give you some information. So it would give you some SMTP connection. The details are rather irrelevant. The important part is Pytest itself will call this automatically, and it also supports cleanup. And that's what we use for Pytest container. And another big thing that Pytest supports is test parameterization. So you can essentially take one test function and execute it with a whole ton of parameters. So in the example below here, this test would be executed 4 times in total. So with the whole combination of all the parameters that are passed here in this decorator Pytest mark parameterize. Okay, that much for the short intro. Let me give you just a few usage examples that would work. So very typical thing that you do is you have some container and you want to build something on top of it. So how would you do this with the plugin with Pytest container? You declare a derived container, you set a base image for it, and then you can, for instance, provide a container file or a Docker file, if you like that name. but the parameter is called container file. Anyway, this is just a really, really simple example. So you would put that in the derived container class, and then you pass it to your test. This test really doesn't do anything super clever. So all it does, it checks whether the package Python 3 is really installed in this. If you would now execute these tests, what would happen is the plugin would pull the base image, then it would build the image, launch the appropriate container, run the test, destroy the container, done. Another thing that you often need if you have services which communicate with something else via ports, you want to forward ports to the host, and this works. Works just by podman run -port and so on. But if you actually want to do this in a reliable way in parallel, and you don't want to parse the output, that gets rather sucky. So you can just pass the parameter forwarded ports to your derived container constructor, and you pass a port forwarding there. You just set the container port, and then in your test function, you get access to the port on the host via this rather long-winded expression, but that just gives you the port that Pytest container chose for you on the host, which is much easier than parsing the output of podman inspect or docker inspect. And then you can, for instance, curl it and see if it, in this case, if it would respond correctly. Another thing that you might want to do is create pods. So for a pod, so far the use case that we support is really just you have a pod and there's multiple containers inside that. So you define which containers get into this, and these containers are just the previously declared classes. So if these need to get built, they will get built beforehand. If they just need to get pulled from a registry, they will get pulled from the registry. You can declare port forwardings for such a pod. And then you would again do the same thing with the parameterization that we use. You just use a different fixture. So it's called, in this case, pod and not container. And what will happen in this case is the plugin will first fetch all the containers or build them, then create the pod, launch all the containers in the pod. Then it will start your test. In this case, we just curl the thing. And after the test finishes executing, it will destroy the whole pod and all included containers. So far I was probably very much not clear on that regard, that all these tests were rather immutable. So we were using one thing which the plugin does, and that's if you, by default, it will launch a container and all your tests will share it, just for performance reasons, because otherwise the tests get dog slow. But sometimes you want to break stuff, or, well, preferably not break, but you want to change stuff. And then you want to have a container for each test. And we have a fixture for that, and it's called container per test. So then you can just do things like rm-rf, everything inside that, and it will not affect all subsequent tests. Or you can decide to uninstall your high-level package manager, and this next test that tries to install something via zipper in this example will still work because it got a different container. If we use the container fixture, this wouldn't work anymore. But by default, if you don't modify anything, I would recommend use the container fixture. That will be much faster. Another thing that you might run into rather frequently, you have a set of tests and you want to run, and you run all of them on the same images or on the same image, and you get very much annoyed by writing this add pytest.mark.parameterize, yada, and everything like that. So instead, you can use the auto container or the auto container per test fixtures. And what these just do, they automatically parameterize the test. So they use a lot of Pytest magic. But how it actually looks like is you declare a global variable called container images, which is just a list of containers. And then you can omit the parameterization. And what will happen in here is if you execute these tests here, each of them will get launched with the 3 containers listed up here, which can be rather useful if you have a bunch of small test functions and you want to have them executed for 10 different containers. Then you just save yourself a lot of typing, and you make everything look much prettier. So you can also have dependencies between containers. And by dependencies, I really just mean you have a container and you build another one on top of it and another one on top of it and another one on top of it. And you don't have to really repeat yourself. So let's assume you take here a base container, in this case Tumbleweed, and you install Nginx into it. And then you also want to have a container with some debugging tools. And as you can see, in this case, we defined the base image as the Tumbleweed class. And in the Nginx _debug, we used Nginx as the base class, as the base. And what will happen in this case, the plugin will find out, okay, I have to use the Nginx debug. For that, I will build Nginx. For that, I'll build Tumbleweed. It will build everything for us, launch the container, etc., etc. So you can also inspect containers if you want to take a look at metadata, for instance, like the username, the command. So this is real, or for instance, the environment, labels, a few of the network configs. So it's kind of Pythonic interface to the output of Podman or Docker inspect, but it doesn't expose everything because there's a ton of stuff that's, in my opinion, also not very useful for testing in most cases. Yeah, I also talked a little bit about container volumes. So in case you want to expose, you want to bind mount a volume or a directory, then you can do that as well. There's, again, a class for that, which you would pass via the parameter volume mounts. So there's 2 options here. You can either give it really a directory on the host that you want to expose, in case you want to mount something specific into your container, or you can just omit it and you'll get a temporary directory that will get fragged afterwards, so you don't have to clean it up at all. This is just, again, a parameter to the container or derived container class. And you would get, the thing would get mounted inside the container. Same thing works with container volumes. The class name is just a little bit different. I think, yeah, so this is really just, in this case, you would get a container with var log just being a container volume, and this one will get removed after the test run itself again as well. Another very useful thing, that's health check. So this is very useful when testing applications, because some applications do take a bit to start up, and then you launch your tests and you connect to them and the tests fail, and then you test it manually, and because you can't type as fast as the machine does, it works when you test it manually because you gave it like a second to start up, but the plugin itself didn't know that. But if you add a health check, in this example, just a curl call that's in there, the plugin will try to do the right thing. So if there's a health check, it will wait for the container to become healthy, and then launch your test. You can manually check for the container health, but unless you apply any settings, you don't have to. So it will try to do the correct thing and launch your test once the container is healthy. If it becomes unhealthy, the test will immediately fail and not even start. If you don't like that, you can also just set the health check timeout to -1 second, and then your container, and then the health will not be checked at all, if you like that. I said you can pick any container engine. That's just an environment variable. So it will use Podman by default if it's installed. Otherwise, it will fall back to Docker. If you have both, you can just set the environment variable container runtime to Docker. And one thing that I'm relatively proud of is that parallel test execution works. Just install Pytest xdist via pip or poetry or whatever else you use and execute it like this with -n auto or number of processes, and you're done. It should work. What I'd like to also mention is we try to clean up essentially all created containers, all volumes, all ports that get created, temporary directories. They are all gone after the test unless you really segfault Python. One thing that we keep around, that's images and intermediate layers during building, just for performance reasons. Otherwise, your tests just take ages to execute and it's not fun. A few users that were mostly involuntarily that got volunteered by me sending aggressively pull requests. That would be the BCI test suite, the scripts of the Kiwi image builder, then a few OBS services, and maybe I convinced you into your project. I'd like to very briefly thank also Jean-Philippe Evard, who worked with me on the initial prototype, and the QEC team at SUSE, who helped me debug a lot of issues on older operating system versions and more exotic architectures like S390X and PowerPC 64. So without them, this wouldn't work. Thanks, guys. If you'd like this, you can find links to the plugin itself, to the documentation, and to this presentation on GitHub. And with that, I would very much like to answer your questions.